It turns out that the Fibonacci sequence satisfies the following explicit formula. For every integer f sub n greater than or equal to 0, verify that the sequence defined by this formula satisfies the recurrence relation f sub k equals f sub k minus 1 plus f sub k minus 2 for every integer k greater than or equal to 2. Now, just to clarify, this is the recurrence relation for the Fibonacci sequence. So the claim that's being made here is that this explicit formula satisfies this recurrence relation. The way we're going to prove this is we're going to evaluate both of these sides separately. So let's start with f sub k. Now, I think the author meant to put an n here instead of f sub n because every Fibonacci number is greater than or equal to 0. The author meant to write n greater than or equal to 0 here, because then what's important is that since k is greater than or equal to 2, then k is greater than or equal to 0, which means that we can replace all of these n's here with a k, since k is greater than or equal to 0. So I'm going to take this explicit formula and replace all of the n's with k's. So this is the left-hand side of this recurrence relation. Now we're going to evaluate the right-hand side of this recurrence relation using the same explicit formula here. Now, since k is greater than or equal to 2, then that means that k minus 1 is greater than or equal to 1, which is greater than or equal to 0. And so that means that k minus 1 is greater than or equal to 0. If we subtract 2 on both sides of this inequality, we get k minus 2 is greater than or equal to 0. So k minus 2 and k minus 1 are both greater than or equal to 0, which must be true in order to apply this explicit formula. So I'm going to apply this explicit formula to both f sub k minus 1 and f sub k minus 2. So now we have to evaluate this right-hand side, which means we need to apply this explicit formula to both of these pieces. So this is going to be kind of long. And so that's what that looks like. That's what f sub k minus 1 plus f sub k minus 2 looks like using the explicit formula. Now we have to somehow simplify this expression down to this blue expression here. And this is going to require some algebra. We can start by factoring out the 1 over root 5 from both terms here. And then what I'm going to do is I'm going to swap these two terms here, so that we can group together the 1 plus root 5 over 2's, and we can group together the 1 minus root 5 over 2's. Now, if you notice, the terms with the 1 minus root 5 over 2 have a negative symbol in front of them. So when we write this out, I'm going to separate the 1 plus root 5 over 2's from the 1 minus root 5 over 2's. Next, I'm going to factor each of these groups separately. So from the first group, I'm going to factor this 1 plus root 5 over 2 to the k minus 1 from both of these terms here. And I'm also going to apply the same logic with this 1 minus root 5 over 2 to the k minus 1. Next, after we've factored out those, what we can do is we can simplify the expression that we have after factoring out these factors. In each of these little expressions, we can combine these two terms by creating a common denominator. So we can think of this 1 here as a 2 over 2, and this one is also a 2 over 2. And then we're going to combine these denominators. Now this is going to be where things get a little weird, because when we simplify this, we get this expression. Now this doesn't look quite like it's the same thing as what we get on the left-hand side. This should be an exponent of k plus 1, but here we have an exponent of k minus 1 and then this weird factor. But I'm going to claim that this thing right here is the same thing as 1 plus root 5 over 2 squared. Now, if we were to square the numerator and the denominator here, we would get 1 plus 2 root 5 plus 5 all over 4, which is 6 plus 2 root 5 over 4. And we could simplify that to 3 plus root 5 over 2. And notice we get the exact same thing here. So it might not look like this is 1 plus root 5 over 2 squared, but it actually is. Similarly, we can rewrite this last expression here as 1 minus root 5 over 2 squared. And you can check that if you square this fraction here. And using the law of exponents, we can group these together to get the same thing as we got on the left-hand side. That last step is a little tricky, but it's simply a matter of looking at the left-hand side to see what we're missing here. We were missing these two important pieces so that we can fix these exponents to be a k plus 1. Thanks, everyone, and I'll see you in the next video.